Okay guys, let's try and understand the types of alcohol that we come across. First of all, we have monols, diols, triols and polyols. Okay, these are the alcohols that we have. Monool because there's only one OH group present in the entire molecule. Two OH group, whether it be aryl or alkyl, there are two hydroxy groups. There are three hydroxy groups. So triol, diol, monool and polyol. Sorbitol is a polyol. It has got 6 carbon with 6 hydroxides. So that's about monool, diol, triol and polyol. Then again further, if we come in terms of allylic alcohol, what do we mean by allylic alcohol? Allylic alcohol is, we are talking in terms of alcohol. So OH is the functional group. Alright. So this becomes alpha carbon because functional group is attached to that carbon. So we call that as alpha carbon. So beta carbon has double bond. So we call it as allylic. Now just come over here. Now this is called as vinylic. Why vinylic? Because again here this is alpha carbon because functional group OH is attached to it. And next to it is double bond. So it is alpha carbon. So unsaturation to alpha carbon is vinylic and unsaturation double bond to beta carbon is allylic. Alright, so okay, so that's the difference between allylic and vinylic. Now in case of allylic alcohol, again we have primary, secondary and tertiary. Obviously primary, why? Because to this carbon one carbon attached. When we come to this carbon, there is 2 carbon attached. So it is secondary. Alright. And this is tertiary because to this carbon 3 carbons are attached. So this becomes tertiary, 3 degree. So 1 degree, 1 degree, 2 degree, 3 degree. Mind you, we have got to see that carbon to which functional group is attached because we are talking in terms of alcohol. So we have primary, secondary, tertiary, allylic alcohols. Alright, okay, then let's come to benzylic. C6H5CH2 is called as benzyl group. So benzylic, so primary, alright, 1 carbon attached. Secondary, because to this carbon there are 2 carbons attached. To this carbon there are 3 carbons attached. So tertiary. So primary, secondary, tertiary, benzylic alcohol. Another thing, if you observe this carbon, it has got sp3 hybridization, sp3 hybridization, sp3 hybridization. I told you, I had given you a shortcut of how to check whether it is sp3 hybridization or not. If there are, see, 3 plus 1 is 4 group. If to the carbon 4 groups are attached, then it is sp3 hybridization. Let's check it out. Carbon, 2 of hydrogen, 1 of OH and another of this aryl group. So 4 groups attached. So sp3 hybridization. So sp3 hybridization. Now again here if you see this, these also are all sp3 hybridization. Let's check this out. So to this carbon, H, OH and this CH group attached. So this becomes again sp3 hybridization. Similarly even here. So if you want to differentiate between sp3 and sp2 hybridization, we find that here, if we check out here, in case of vinylic alcohol, to this carbon is attached H, attached OH and another group. So there are 3 groups attached. So sp2 hybridized state, 1 of S and 2 of P. Alright, sp2 hybridized state. Okay, let's get back to our vinylic alcohol. So vinylic alcohol is, as I explained, since the double bond is adjacent to alpha carbon, so we call it as vinylic. So again in vinylic, there are primary and secondary vinylic alcohols. Tertiary not visible because double bond is over here. Alright. And another important thing is it has sp2 hybridized state. Alright. So that's yet another difference. sp3, sp3, sp3. Here it is sp2 hybridized state. Okay, now since we are doing alcohol, let us also check out a bit of ethers. Now when we check out ethers, we have 2 types of ethers. One is symmetric ethers and the other one is unsymmetrical ethers. In symmetrical ethers, we call it a simple ether when when both the groups attached are same. Methyl, methyl, ethyl, ethyl, aryl, aryl. Alright, so this is symmetrical ethers. In unsymmetrical ethers, we have two different groups attached. Methyl, ethyl. Methyl and aryl. So when two different groups are attached, we call it as mixed ethers. Alright, that's about information between alcohols and ethers.